Hello everyone, welcome to Math Academy. In this session, you will learn the most important questions in the chapter Applications of Trigonometry. So we move to the question. The angle of depression of a car, angle of depression. So here it is angle of depression. Parked on the road from the top of a building 150-meter high. And the angle is here, the angle of depression is 30 degrees. So if I am marking the alternate interior angle, then this will be 30 degrees. So the distance of the car from the tower is asked. So the adjacent side x is given asked. So you have to calculate here tan 30. Opposite and adjacent is involved over here. Opposite is 150, adjacent is x. And we know tan 30 is 1 by root 3. So 150 divided by x. So from this do cross multiplication and find your x value. So x is equal to 150 root 3 meters. If the height of the vertical pole is root 3 times the length of its shadow on the ground. So shadow on the ground can be taken as x. So your data, the height of the vertical pole is root 3 times. So root 3 times x. And then the angle of elevation of the sun at the time is, so this theta is asked in the question. So opposite and adjacent is involved in this problem. So tan of theta is equal to root 3x opposite and x is adjacent. So these two will get cancelled. So tan theta is equal to root 3 and root 3 is nothing but tan of 60 degrees. So theta value is equal to 60 degree. If a tower 30-meter high cast a shadow of 10 root 3 meter long on the ground, then what is the angle of elevation of the sun? So this is asked. So opposite and adjacent is involved in the question. So tan theta is equal to 30 divided by 10 root 3. So this will cancel. So root 3 into root 3 and divide by root 3. So tan theta is equal to root 3. So theta will be equal to 60 degrees. Two ships are approaching a lighthouse from the opposite direction. So AD is our lighthouse. The angle of depression of the two ships from the top of the lighthouse are 30 and 45 degrees. If the distance between the two ships is 100 meter, that is B to C distance. Find the height of the lighthouse. So H has to be AD will be calculated. So in this problem, look at your diagram. So here we are involved with the two triangles ADB and our triangle ADC. So you have to consider two triangles individually, and here in the BC distance is 100 and D to C we don't know, we will take it as x. So obviously my B to D is 100 minus x. So first consider the triangle ADC. Consider the triangle ADC. So here the angle is 45. So tan 45 degrees is equal to opposite is h, adjacent is x. So h by x. Tan 45 is 1. So h by x, which is equal to x is equal to h. So this is our first equation. And coming to the next triangle. So triangle ADB. Look at your diagram ADB. So tan 30 is equal to opposite side h, adjacent side is 100 minus x. So tan 30 is equal to opposite h, adjacent 100 minus x, and tan 30 is 1 by root 3. So do your cross multiplication and solve for your data. So 100 minus x is equal to root 3h, and now you can use your equation number 1. Use equation number 1. Equation number 1 is x is equal to h. So 100 minus h is equal to root 3h. Bring h to one side and number to the other side. So 100 minus root 3. So which is equal to, 100. Bring root 3 h on the one side and number on the other side. So your data will be, so root 3h plus h. So if you take h outside, so root 3 plus 1 is equal to 100. From here, if I am finding the value of h, then this will be this data. And here it is involved with our root 3 plus 1. So we can do rationalization process. So 100 divided by root 3 plus 1 into root 3 minus 1 divided by root 3 minus 1. And root 3 square minus 1 square. So this is equal to 2. So we can cancel this value. So 50 root 3 minus 1. H is equal to 50 root 3 minus 1. Suppose if you are given with your root 3 value 1.732, then you can do your value. So 1.732 minus 1, so 0.732, which is equal to 36.6 meters. This is the height of our lighthouse. On a straight line passing through the foot of the tower, 2 points C and D are a distance of 4 meter and 16 meter from the foot of the tower respectively. If the angle of elevation from the point C and D of the top of the tower are complementary in the sense theta and one another angle is 90 minus theta. Find the height of the tower. We are considering at the point C angle is theta and at the point D 90 minus theta. So we are having two triangles. So triangle ABC and triangle ABD. So you can consider. So first you take your triangle. So triangle ABC you can consider. So in the triangle ABC, tan theta is equal to H divided by 4. And tan theta is here. This is our first equation. And consider the next triangle ABD. So here it is tan of 90 minus theta is equal to H divided by our data is 16 overall. So tan of 90 minus theta is equal to H divided by 16 and tan of 90 minus theta is based on complementary angle formula. This is cot theta. So cot is equal to cot theta is equal to H by 16. Cot is reciprocal of tan. So tan theta is equal to 16 by H. So this is equation number 2. So look at your first equation and second equation. On left hand side the value are equal to tan theta. So we can equate the right side part our two equations. So H by 4 is equal to 16 by H. So H square is equal to 4 into 16. So H is equal to root of 4 into 16. So 2 into 4, 8. So since all the data is in meter, then this is equal to 8 meter. The 8 here, H is nothing but height of the tower. So height of the tower is 8 meter. An observer 1.7 meter tall is 2 root 3 meter away from the tower. The angle of elevation of the eye of the observer from the top of the tower is 30 degrees. Find the height of the tower. So here AB is the height of the tower. So and here look at your triangle AED. So the theta value is equal to 30 degrees and our AE value is AB minus the height of the observer 1.7. So let us consider AB is equal to H. So H minus 1.7, that is our AE. And in your triangle AED, if I am considering tan 30 is equal to H opposite side H minus 1.7 divided by adjacent side is 20 root 3. So that you can calculate your H value by doing the cross multiplication. Tan root 30 is 1 by root 3. So now do your cross multiplication. So h times 20 root 3 is equal to root 3 times h minus 1.7 and this root 3 and root 3 will get cancelled. So 20 is equal to h minus 1.7. So h is equal to 20 plus 1.7, that is equal to 21.7 meters. That is nothing but our height of the tower. An observer 1.5 meter tall is 28.5 meter away from a tower 30 meter high. Find the angle of elevation of the top of the tower from his eyes. So here CD and AE are observer height, that is 1.5, and from the ground the height of the tower is 30 meters. So in this triangle, if I am considering this is ABC DE. So here in the triangle ACB, BC is data as nothing but 30 minus the observer height 1.5. So that is equal to 28.5 meters. And in this triangle, if I want to find out the theta, so tan theta is equal to opposite side 28.5 divided by adjacent side is also 28.5 is equal to 1. So tan theta 1 in the sense then theta is equal to 45 degrees. So that is the angle of elevation for this problem. If the angle of elevation of the top of the tower from two different points A and B, here A is greater than B from its foot in the same direction from it are respectively 30 degrees and 60 degrees, then find the height of the tower. So AD is the height of the tower here. Here we are having two triangles ADC and ADB. So first take your triangle ADC. So triangle ADC. So in that our value is theta is 60 degree. So tan 60 is equal to h divided by the base is b. So h is equal to, so this value root 3 is equal to h divided by b. So from here you can calculate your b value. B is h divided by root 3. So this is first equation. And take your next triangle ADB. So in the triangle ADB, tan 30 degrees is equal to opposite side h by adjacent side a. So 1 by root 3 is equal to h divided by a. So from here a is nothing but root 3 times h. So this is equation number 2. So now if I am multiplying equation number 1 and 2. So left hand side we are getting our data a into b. And right hand side h by root 3 into root 3h. So root 3 will get cancelled. So h square is equal to AB. From here you can find the h, that is nothing but in this problem height of the tower. So height of the tower is equal to root of AB meters. The top of two poles of a height 16 meter and 10 meter are connected by a wire of length L meter. If the wire makes an angle of 30 degree with horizontal, then find L. So in this case, AE in our diagram, AE and our BD are our poles. So A is 10 meter and BD is our 16 meter pole. So here look at our diagram. So AE is equal to CD is equal to 10 meters. So BC is equal to 16 minus 10. So the BC is equal to 6 meters. Now consider the triangle BCA. Then here we want to find out the value of L. So 30 degree is given and opposite side is involved, and opposite and hypotenuse are given involved in our problem. So you have to take your sign. So sine of 30 degree is equal to opposite side 6 and hypotenuse L. So sine 30 is 1 by 2. So 1 by 2 is equal to 6 by L. So do cross multiplication. So L is equal to 12 meters. So that this is the value of our wire L. So that is 12 meters. In the given figure, AD is equal to 7 root 3 meters. Find the value of BC. So BC is nothing but BD plus DC. BD is given as X and DC is given as Y. So BC is equal to X plus Y. So look at our diagram. So here we are having two triangles ADB and ADC. So you can take one by one. So triangle ADB. So this is tan of 30 degree is equal to opposite side 7 root 3 divided by x, and this is 1 by root 3, 7 root 3 divided by x. So x is equal to 7 root 3 into root 3. So 7 3s are 21. X is equal to 21 meters. And now for your y calculation, consider the triangle ADC. So triangle ADC, so tan 60 degree. Tan 60 is equal to 7 root 3 divided by y. So tan 60 value is root 3. Root 3 is equal to 7 root 3 divided by y. So y is equal to 7 root 3 divided by root 3. So that is equal to 7 meters. And we know our BC is x plus y. X is 21 and y is 7. So together the value is 28 meters. if the shadow of the tower is 30-meter long when the elevation is 30 degree. What is the length of the shadow when the sun elevation is 60 degree? So let us consider AB is the height of the tower. So AB is equal to H, and we are considering BD is equal to Y in this problem. So we are having two triangles ABD and ABC, and you can consider first ABC triangle. Our ABC triangle here, the value is tan 30 degree, opposite H, adjacent is 30. So 1 by root 3 is equal to H divided by 30. So H root 3 is equal to 30, and H is equal to root 3, 30 divided by root 3. Do your rationalization process. So 30 root 3 divided by 3. So this is H is equal to 10 root 3 in this case. And now you have to find the value of your YBD when the angle is 60 degree. Now consider your data H is equal to 10 root 3 while considering your triangle ABD. So in the triangle ABD, you can consider your tan 60 opposite H and adjacent Y. H is nothing but 10 root 3. So tan 60 is equal to H divided by Y value, and root 3, H value is 10 root 3 and Y. So Y is equal to 10 root 3 divided by root 3, which is equal to 10 meters. That is, this is the shadow length. 10 meter is the shadow length when the sun's elevation angle is 60 degree. The angles of depression of the top and bottom of a 50-meter height building from the top of the tower are 45 and 60 degree respectively. Find the height of the tower and the horizontal distance between the tower and the building. So in our diagram, so you can mark your data. So this is my A, B, C, D, E here. So here CD is our building, and CD is equal to BE, that is given as 50 meter. So AB is our tower in this problem. So let us take AB is equal to H meter. So here it is angle of depression. So you have to mark your angles properly by taking alternate interior. So BD is the distance between the tower and the building. In this case, let us take X. So BD is equal to X meters. So now you have to consider your triangle AEC. So in this triangle, AE value is equal to AB minus 50. So H minus 50 meters. And here in our triangle, tan 45 is our data. So you can consider tan 45. So tan 45 degrees is equal to opposite H minus 50 divided by adjacent X. So tan 45 is 1. So H minus 50 divided by X. So X is equal to H minus 50. So this is our first equation. Now consider the next triangle ABD. The triangle with the angle 60 degree. So triangle ABD. So tan 60 is equal to opposite side H, adjacent side X. So root 3 value H divided by X. So this is nothing but X is equal to H divided by root 3. So this is our second equation. If the in equation number 1 and 2, the left hand sides are equal, so I can equate the right hand side part. So H minus 50 is equal to H divided by root 3. You have to find your H value now. So for that, so you can take your data. So you can multiply your cross multiply. So H root 3 minus 50 root 3 is equal to H. Bring your H on one side. So root 3 minus 1, which is equal to 50 root 3, and H is equal to 50 root 3 divided by root 3 minus 1. So do rationalization. So 50 root 3 times root 3 plus 1 divided by root 3 square minus 1 square, that is 2. So you can cancel your value. So 25 root 3 times 3 root 3 plus 1. So you can take your root 3 inside of your data, so that your value will be 25 times 3 plus root 3. So if you are given with your root 3 value, you can supply your data. So 25, you can take 25 inside. So plus 25 root 3 meters. So if I am doing with data, so this is our H value. That's all. And what is asked in our question? So the horizontal, find the height of the tower. That is one part. Second part is the horizontal distance between the tower and the building. That is our x value. So x is nothing but h minus 50 we know. So x is equal to h minus 50. So x is equal to h value. If I am supplying my root 3 value, then this will be 118.25 meters. So 118.25 minus 50, which is equal to 68.25 meters. This is the distance between the building and the tower. Meet you in the next video. Bye.